Hi everyone. Today I want to present this paper, a novel approach for code smells detection based on deep learning. This paper is co-authored by Tao, Fu, Xue, and Lu Qun, and I am Tao Lin. This paper was published by EAI International Conference on Applied Cryptography in Computer and Communications. Compared to software bugs, code smells are more significant in software engineering research. It is not easy to detect code smells through traditional methods. In this work, we propose a novel code smell detection approach based on deep learning. The experiments show that our work achieves high scores in terms of F2 score and kappa values. Code smells are increasingly generated by modern agile software development. This is because code changes are much more frequent and occur on a daily basis for large software companies and dominant open source communities. Although there are many more tight approaches to detect code smells, these methods have some defects. Due to the frequent changes, it is increasingly probable to generate code smells overheads. Code smells, like software bugs, are a serious problem in modern software. Nowadays, the code smells are being researched by many practitioners. Software developers are not aware of what is the code smell, although they are aware of software bugs. Thanks to Integrated Environment Development Kit (IDE) that can provide many instant suggestions and notifications when there are bugs. The question here is how to detect code smells effectively, and what is the motivation for detecting code smells. Although there are many more tight approaches to detect code smells, these methods have some defects. We leverage deep learning on code smell detections. There are mainly two categories of deep learning networks. One is recurrent neural networks, and another is convolutional networks. Convolutional networks have already demonstrated its usage by leveraging hierarchy features. In this paper, we use fully convolutional networks for code smell detection based on semantic features. We will define the type of neural network we use and explain how it is used to detect code smells. An advantage of using convolutional network is its ability to identify and use local correspondences. In recognition and machine learning, convolutional networks are increasingly significant. Convolutional network presents the improvements on image recognition. An example is using convolutional network on local correspondence. In software engineering, we definitely can use this kind of information for code smell detection. To our knowledge, this is the first work to train a convolutional network for code smell recognition. The inference is much more improved through convolutional network. Unlike previous work that needs additional information for code smell detection, this work does not use any existing information for code smell detection. One of the major challenges in code smell detection is to find relationship between code semantics and code location. There is a trade-off between identifying the correct semantics compared to identifying the correct location of the smells. Although there are several success stories from image recognition by using deep networks, it is hard to transfer these approaches to software engineering, which is more deterministic. Fully convolutional network has been used for one-layer computation and has the potential to deploy to multi-layered environments. We can define a multi-dimensional array to represent the convolutional network, h times w times d, where h and w are space dimensions, and d is the channel. The first layer is our source code input. The second layer is the network for sequence modeling. For example, the inputs are x0, x1, x2, x3, x4 until xn, and the outputs are y0, y1, y2, y3, y4 until yn. The final output will be reshaped to one-dimensional array, where size will be d times 1024. This output array will be dilation blocks. For the encoder task, we should process noise. Each layer in the encoder is processed by normalization and linear analysis. With recent development in software engineering, it is easy to find software bugs using several methods from compiling to running. Our work is based on the state-of-the-art deep learning method for detection and recognition tasks. Firstly, we transform the software source code to XML file in order to be processed by deep learning models. Then, there are two steps: code segment proposal and classification. The code segment proposal leverages the heuristic search to generate following inputs. These segments are processed by CNN classifier. We try to use RCN otherwise. One of the main reasons is that RCN uses selective search algorithm, which is time-consuming. We use the following equation for segments. In this equation, seg is the segments, R is the rule of limits, and P is the process variable. Q is the next graph input, I is the interception, and D is the next destination. We use an open source database published by the author's previous work. The experiment results are shown on the following table. And we try to detect this kind of code smell categories: long method, lazy class, speculative generality, refuse bequest, duplicated code, contrived complexity, shotgun surgery, and uncontrolled side effects. From this table, this work achieves high performance in terms of F2 score and kappa value, especially for the category of uncontrolled side effects and contrived complexity. In this work, we conducted a research for code smell detection based on deep learning. Our solution uses convolutional neural network for training a model to detect several common code smells problems in software engineering. The solution achieves satisfied F2 score with average above 0.75 and also achieved a satisfied kappa value with average above 0.8. And part of this work is from previous PhD research at the Pennsylvania State University before I joined Amazon. And thank you